but hopefully it's a little bit of review / just giving you some background information. So first word we're going to do is variable. Okay, variable. We did that one yesterday. Can anyone remind us what is a variable? It's a letter that represents a letter. Nope, I said that wrong. A letter that represents a number. And it can change, right? So usually we use a variable for an unknown, a number that we don't know the value of unless it tells us. But it could switch. And it's an unknown number that looks like a letter. So it might be x, but remember that x is secretly like a 3 or secretly a -4. Like a number undercover. Number in disguise. All right. Next up, we got the word coefficient. What's it? Coefficient. So with coefficient, math, we like to really use our suffixes, our prefixes, our bases. We like to use those word parts. What prefix do you see in that coefficient? Co. And what does co mean, or where other word, blah, blah. What other words use co? What? Codependent. Like together, yeah, like co-worker. When we see that co means together or to be with each other. So coefficient is the number multiplied with the variable. Have a good day. The idea of with comes from that co. It's together, so it is with it. And it's that number being multiplied with that variable. All right, and then our last word for just the first little bit here is constant. So if you have a little brother that is constantly annoying, what does that mean if you're constantly annoying?
All the time.
All the time. You're at that same level continuously. You're always at that level of annoying. If Miss Morel is constantly amazing, that means I'm always amazing, right? I never change. Every time you walk into a class, you're like, dang, Miss Morel, she's amazing. Okay? So a constant is a number without change. And remember, a change happens when we have a variable. So a number without a variable. We don't have that change. That's a constant. Also known as just a number. So we're going to apply this, and we're going to label and mark up a little bit of an expression. So here we have our expression. And for our expression, we're going to write kind of in big letters, not letters, numbers, I don't know, big font, 3x plus 2. And that's an expression because we have multiple parts. And social emotional skills, showing a facial expression would be like showing that you're happy or that you're sad. That's a facial expression. In math, an expression shows us some part of math. It gives us a little bit of a taste. Okay, so what in that expression is a variable? X, how did you know? It's a letter. But really, that x is a number. Okay, so I'm going to color code that. I did orange and orange. If you don't feel like color coordinating because you're lame, I guess don't. But that's our variable.
How dare you pull that?
If you want to write next to it variable, you can. If you feel like you get it, you don't have to. It's your choice. Especially if you color code it, you might not need that label. Alright, I'm going to use green next for coefficients. So coefficient is that number being multiplied with the variable. Why is it 3? How do we know it's being multiplied? Good. Remember when two things are right next to each other, that usually means to multiply. So that we're multiplying those two little things. So this 3 is that coefficient. If you want an extra label, you can write it down with that. If you don't need the extra label, don't do it. It's your choice. It's your notes. So a coefficient is the number multiplied with the variable. Something else you might want to write there, if you want to, is like next to. It's like the number next to the variable. Because if this variable is a 2, what does this turn into? Yeah, 3 times 2 is 6. If this x turns into a 7, does that change? 3 times 7, is that still 6? No, that'd be 21, right? Okay. What about our constant? Our constant is going to be the number that doesn't have the variable. And in this case, it's 2. Good. Nice job, Abdiaziz. So that constant doesn't change depending on what x is. So when we said x is 2, is that going to change this 2? Nope, it's still 2. If x is all of a sudden a 7, what's that? Still a 2. So it stays the same or it doesn't change. If you want to write that in, you can. If you feel good, you don't need to. Remember, these are your notes. You get to mark them up how you feel you need to. Okay? As we start off the year, I'll write a little bit more in the notes, and then as we go, you can decide what you would like to write versus what I write. All right. How many parts are there to this expression? It looks kind of like there's 3 parts. We have 3 words, right? But if we break it up, how many, total parts? Oh, you're right. I'm not asking the question correctly. You're thinking that plus. I don't know. Ignore that question. Pretend I didn't ask a question. We have 2 parts. We have this 3x is going to be 1 part. And this 2 is another part. In expressions, we call those parts terms. So this is 1 term, and this is another term, which really just means part. So if we have a coefficient and a variable, because they're being multiplied together, they count as just 1 part together. Because they are together. Hence the coefficient, together. Alright. How are we feeling? Good? It's a lot of me talking today, so you guys gotta tell me when I need to stop talking, okay? If we need a stretch break, we can do a stretch break. Alright, next up we got some like terms. If you are like someone, okay, what does that mean? You're similar. Does that mean you're exactly the same? No. So Taylor, I'm going to pick on Taylor because I know Taylor's older sister, Alexis. Taylor is like Alexis. Does that mean that they're exactly the same human? Do they act exactly the same? No. When I say that Taylor is like Alexis, what does that maybe mean? They look similar. Maybe they act similar. Maybe they have like a certain word that they say a lot because they're sisters. They grew up in the same place. I don't know. Maybe just the way they do this looks the same. Okay. Like terms is going to be parts with the exact same variables. Parts with the exact same variables. You guys stop talking so we can focus? That was a joke. You guys really like the quietest class. It freaks me out. Alright, so for like terms, if I have 17W, who can tell me a term that has that exact same variable? 16W? Okay, 16W. What else? 12W. Can someone give me one that's not positive? Negative 3,000W. What makes those all like terms? That W, that variable. So you have that W, 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 W. Does it have anything to do with that coefficient, that number in front? Nope. All that matters is that we have all of those W's. Okay, now here's a question. And this one I'm going to put in and watch carefully and decide if you want to put it in or not. What about 32WX? Does that have the same variable? Is it the same exact variable? No, because this one has a W, but what else does it have? That X. So I'm going to actually circle that and cross it out. So if you want to write it, just so that you know that's not an example, if you want to write it and cross it out, say it's not, or maybe you write not the same or not like terms next to it. If you don't want to write it because you know that's not a like term, that's fine too. Alright, so that one does not work. Even though it has a W, it's not the same. Okay, when we combine like terms, we're going to add coefficients. So this is going to be our first example here. Example number 1. If I have 6J plus 9J. So one way we can think about that is if I literally have 6 J's. 6 times J means I have 1, 2, 3, 4, 5, 6 J's. That's 6 J's. If you don't know what those are J's. J, 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 6 times. And I'm going to put it together with 9 J's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, you don't have to write out those J's if you feel good. How many J's total would that be together? 15. So instead of writing out all those J's, what two numbers could I have added together? Close, not the coefficients. That's all right, you almost said it. Those coefficients, those numbers in front, we do 6 plus 9 would give us 15. If you need to write it out, that's okay, but you can also use a calculator. All right, next up, we got a property called the commutative property. Commutative property. Sometimes we like to look at that and our brain wants to say community, but it's not. No N, just commutative. No N, commutative. If you commute to work, what does that mean if you're a commuter? What? Yeah, you travel to work. You go to work. So sometimes at colleges there's like commuter parking because not everyone stays on campus. So those commuters get special parking because they don't just live at campus. So commute means to travel. How many of you commuted to school today?
All of it.
Yeah, did anyone sleep here last night? You like nodded your head like, yeah, I did. Yeah. Okay, how did you commute to school? Car? A bus? Bike? You did not ride a helicopter here, liar. Okay, commutative. So commutative means to move or to travel. So commutative means we're going to move terms around. And I'm just going to write move terms. So commutative means to walk around, move around, switch in different places. Okay. Next up we have associative. And again, that one's kind of a goofy one to spell, so be careful as you spell it. Especially if you decide to abbreviate it. Watch how you abbreviate that one. Alright, so to associate with someone, if I'm over here associating with Nasro, what does that mean that we're associating? Helping? Sure, I could be helping her. Communicating. It's like we're hanging out. If you associate yourself with Apollo, let's say you go to the Apollo soccer game tonight, or you go to the Apollo swim meet versus Sartell, because that's going to be great. Okay, if you associate yourself with Apollo, what does that mean?
You're active with it.
I work for Apollo.
Yeah, maybe you work for Apollo, you go to Apollo. When people look at you and they judge you, if you're really, really nice, they're going to be like, dang, people from Apollo, so nice. If you're really rude, they're going to be like, those Apollo people, they're nuts. Okay? So associate means to kind of group things together. So we're going to say group together. And in math, what symbols do we use to group together? Parentheses right now. We have lots of grouping symbols, but for right now, we're going to use those parentheses to group together. So commute means to move. Associative means to group. How are we doing? Still bored? A little bit? Yeah. It's kind of a lot going on. Alright, so this commutative and associative, in intermediate algebra, we aren't, let me say that again. In intermediate algebra, we're going to use these a lot. We don't always take time to name them. Sometimes our brain just does it, or we just do it ourselves without taking time to be like, oh, this is the commutative property. Oh, this is the associative property. Big thing with these properties is that it has to be all adding or subtracting. This only works when it's all, oh, you can't do that. All adding or subtracting. So if I do 3 plus 4 plus 2, what's that?
9.
Yep, totally knew that. Okay, if I switch those around, let's move them around in a different order. 4 plus 2 plus 3, so 4 plus 2, 6, 6 plus 3, 9. If I do 3 plus 2 plus 4, What if I group it differently? Like if I do 3 plus 4 plus 2. So here I have to do grouping symbols first. 4 plus 2 is 6. 6 plus 3, 9. If I leave it in the same order, but I group 3 and 4 together, guess what? 9. So it works when we have all that adding. Now this is something that you maybe did in pre-algebra where you took time to go through it with just numbers. In algebra, we're going to do it with these expressions that have variables. So this is problem number 2. Example 2. Again, you can't see that. Crushing it. All right, and our directions are going to be to simplify. When you hear something to simplify, what does that mean? Get easier? It's nicer to work with? If I tell you to put something in simple terms? Easier to understand? Yep. Good. All right, so simplify means that we're not necessarily going to get one answer, but we're going to make it easier to work with. So I have 16 plus 12c minus 5 plus 3c. So 16 plus 2c minus 5 plus 3c. How many terms are there right now? There's 4 currently. There's 16, 12c, a minus 5, and a 3c. But do we have groups of like terms? Yeah. What's one of the like terms? 16 and... Ooh, I like that you said negative 5. How did you know it was 16 and negative 5? Yeah, that minus tells us it's really going to be a negative 5 or that minus has to stay. What do we call these numbers? They're like terms and they are constants. Yep, you got it. Okay, what other like terms do I have? Good, 12c and 3c. So if we were going to show our work, which throughout this year we'll start showing less and less work as we go. Today we're going to show our work though. The first thing that we're going to do with those like terms, yes? I don't know, man. I wasn't paying attention to that anymore. Good question. All right, Lucy was looking back up here at our definitions. I should have done, I don't know what I should have done these in blue, right, for my constants. Okay, I just did 2 other colors. Is that okay? I refreshed my brain.
No, it's not okay.
Well, too late. All right, so what I'm going to do is put my like terms together. So I'm going to do 12c. And what do I want to put next to my 12c? 3c. I want to put those c's together. Those are like terms. What else do I want to put together? 16 and negative 5. Now there's 2 ways you could do that negative 5. You could write it as minus 5, or you can rewrite it as a plus negative 5. As long as that minus is somehow attached to that 5. It's traveling with that 5. Alright, so now I have my c's together. And I have my constants together. So which property was that we switched them around? Commutative. Now, according to our order of operations, when I add, I have to add left to right. Right now, could I add left to right? Could I do 12c? Could I take that and then add it to 16? No. So technically, again, this is where we start not showing our work as mathematicians because we're lazy, is we do 12c plus 3c, and we're saying those belong together. That's what we're going to add together. And what else are we going to add together? 16 and negative 5. Now, a lot of times we just do those v's and like, oh yeah, these go together, these are, and we're done. So this is probably one of the only times today and during this practice that you'll see that like I actually, that's how I spell associative. That's our associative property. Okay? And then we just combine those like terms to get rid of that. So what is 12c plus 3c? 15c. Good. What numbers did you actually add together, Taylor? Good. Those coefficients. The 12 plus 3 make 15. And what is 16 plus negative 5? 11. How do we know if it's a positive or a negative? Yeah, between those two, do I have more positives or more negatives? I have more positives, so it's going to end up with a positive. Now, can I combine a 15c and an 11? Nope, not right now. So not until we know what that c is. Right now, no one told us what that c is what, so we just leave it. Cool. I am running out of space, so I'm going to flip to the next page. I have about 3 lines left. The next thing you might want more. I don't know. You do you, bro. All right, so I'm going to flip to the next page. We have one more property we're going to learn today. Can anyone kind of remember maybe from Algebra 1? We have commutative, associative, distributive. Good. Distributive is going to be that next property. So I'm flipping to the next page because I'm out of space. All right, distributive property. If you're going to go and distribute flyers to your game, what are you doing? Handing them out, yeah. The lunch serve. Orange chicken. Best day ever, right? No? You guys don't like orange chicken?
Yeah.
Is the hype too much? Hype's not real? Doesn't live up to the hype? I don't know. I like orange chicken. Y'all crazy. Alright. So, distributive property. This happens when we have like an A parenthesis B plus C. Is that my phone? Again? I did. She's saying you won. So it should already be a sign saying you're good to go. I think I just have to hit through on it. Alright. So, what does it mean when this A is touching that parenthesis? Multiplication. So can we do that multiplication before grouping symbols? If you look at our order of operations, does multiplying come before grouping symbols? No. So this means that we would have to add B plus C first. That doesn't always happen to be the case. So what the distributive property tells us we can do is to multiply each part to get rid of the parentheses. And I'm too lazy to write parentheses, so I'm just going to do that. Just if there's something in the hallway. We're just getting into the room. Thanks. So, okay, so we're going to multiply to get rid of those parentheses. So this A on the outside, we're going to go pew, pew. And we like to do 2 arrows. And both arrows start at the A. So it goes from A to B. And we draw another arrow A to C. Because we're multiplying that whole inside by A. So that will look like, for our answer, we'd write A times B plus, and we're going to have that A again, A times C. All right, we have 2 more examples. We're going to do one more together, and then we'll get some time for you to practice, and we'll end together. All right, this one we're going to keep it simple with that distributive property. So number 3. Are we in example 3? Example 3. if I have 5 times the quantity of 6k plus 2. According to my order of operations, what is this telling me that I have to do first? I have to do that 6k plus 2. Can I add 6k and 2? No, those are not like terms. So to make this easier to work with, we're going to get rid of those parentheses by doing that multiplication. But when we multiply those insides, we have to multiply all of it by 5. So I like to make some noises here. I go, pew, pew. Okay, you're going to hear me say that a lot this year, like pew, pew, and you're going to be like, oh, distribute. Get those together. So this is going to tell us that we're going to do 5 times, what's the first part? 6k. And we're going to do 5 times 2. If you want to sneak a plus sign in there, you can. If you want to color code that, don't pay attention to the colors at the beginning of the lesson. Sorry. We have a 5 here. And we did that 5 2 times. We have 5 times 6k and 5 times 2. Or you could use a different color if you'd like. Alright, so what does 5 times 6? 30. So we get 30k plus 5 times 2, 10. Alright, we're going to just take a quick time to practice. You can practice with a partner at your table, or you can practice on your own. You're going to take out a whiteboard. We're not done with your notes yet, so leave those out. We're going to write an example in our notes after you get some time to practice.
Why'd you highlight the 5s?
Because there's 2 of them. We went from 1 5, and then we handed the 5 out. Both. Both the 5. I don't know. It made sense in my brain. Yeah, do you want to fill out your helps? Okay. On a whiteboard, you are going to choose one of the 3 problems to do. If you finish the problem you're on, you're going to try the other problems. So your options are, you can do problem A, and you'd write that down, solve it, simplify it, not solve it. You could do problem 2, those are Q's, or you can choose the green problem. So you're choosing either problem A, problem 2, or the green problem. If this is the first time you've seen distributive property, you might want to choose A. If you kind of remember it from last year, you're ready for a step up, try problem 2. If you're like, this is easy peasy, I can do this with my eyes closed, try that green problem. Okay? So go ahead and do that on a whiteboard. You can pick whichever one you want to start with. If you finish, try the next harder one, more challenging one. One level down. You don't have to do all 3 unless you really want to. So you're choosing one and solving that one.
You got it.
Did you get it? Yeah.
Which batch is missing?
The 800s. No. Just gotta keep hitting it. I think it'll happen too with the auditorium, but I'm not sure.
2 2.
You can try. I think that just... Ah, nice. Perfect.
Can I go?
Yeah, you can go. I'll also approve it.
I do meow.
You write that nice and over there.
Me too.
Just nice big several.
Me too.
Yeah.
You2. You2, which one are you going to put?
No, I mean like it's birthday.
That's the one that you're multiplying.
Mine too. Yep.
False.
See? I just did it. You could watch it happen. You can watch it.
Will you throw this and then that one where we want to do
Just this way. That's a Q.
Just this one, this one. Yeah, come out nice and big.
And then go round. So that'd be
Nice.
2Q plus 5Q. No. Oh, okay. It's 15Q. 7Q. What's 3 times 5? No. 15. You're changing it. No, I'm not. You're changing it. It's 7Q. 17. No, it's 7. Yes, it is. You have to use computer property to switch them around. You don't. You do. That's the whole point of number 2. Is it the whole point?
She said I did it right.
Boo.
Or maybe she was
you
lying.
can switch around. You don't have to.
Or maybe she
I
was
just
lying.
think it's
Or maybe she
7.
was lying. Or she said I did it right.
7Q
17.
plus
It's 17.
4.
So close.
That's what I got.
17.
Nope,
So
it's
the
7.
It's 17. She told me I did it right.
Oh.
Negative 7, right? Oh, so that's where you're
How is it 17?
Maybe she lied to me.
So how is it 17?
Negative 7.
What's 3 times 5? 15.
15.
15Q plus 2Q is 17Q.
Wow.
No, you're supposed to show your right.
Read the problem. You don't need to. No.
Oh, I have a question. How is it 17?
Because
We had a really hard times that.
okay, so see how you did the 6?
Yeah.
Pew, pew. So where are you gonna go? Pew pew over here. So that one we're adding, so not that one. Which one are you multiplying? Yeah, so that one we're gonna go pew pew. Ignore that 2Q just for a second. Do your pew pew and then that one. Okay? All right. Couple more seconds here.
Should that be
You got it.
Q plus 15 plus 15 here? Yeah. 2Q and 15.
You do it right.
What?
It's not
Where's
quite.
the 4 from it?
It's a little craziness. The 4. It's either 3 times 5, right? And you have to do 3 times. Do that. Which has to be a 4. Alright, here we go. Back here, take a look. Those of you that did the first one, you had BSCs do this one. So we distributed the 6. 6 times 3j. Now BSCs put a plus here, and that's okay, but where did he keep that minus then? He put that minus with the 4. So 6 times negative 4. So then 6 times 3 was 18j. 6 times negative 4 is negative 24. Could you write your answer like that? Yeah, either one is right. Either you can do a plus of negative 24, or you can write a minus. Either way. Alright, question 2 we have over here. You are thinking way too hard about that. You're good. Just chill. We'll work on it together. Alright, over here. As you can see, it's big enough for everyone to see. Alright, what are we multiplying those parentheses by? What's right in front of the parentheses? Right in front is that 3. Okay. So, Finn decided that we're going to distribute that 3. I got it this time. I almost spelled you wrong. That wasn't right. We distributed that 3. 3 times 5, Q, and then 3 times 1. So 3 times 5 is 15. 3 times 1 is 3. What was the extra step we had to make on this one before getting our final answer? Yeah, we have to combine those like terms. Add that 15Q and 2Q, and we get 17Q. Beautiful. All right, let's take a look over here, where this one is just very lovely done. But for some reason, we're just really worried about it. We wanted to stare at it for a real long time. All right. In this one, where is the multiplying? What number are we multiplying the parentheses by? 7. Can I underline it? Is that okay? So we're taking that 7, and we're going to distribute that 7. Now, is that just a 7, or is that a negative 7?
Negative 7.
Yeah, that minus in front tells us it's a negative 7. So what's negative 7 times 3? Negative 21y. Negative 7 times negative 4. Negative times a negative, positive 28. Why didn't we do negative 7 times 2y? Good, it's out of those parentheses. Then after that, then it's just like how we did before. I really like that we boxed this negative 21y, 2y. That makes negative 19. And then we still even took our time, which was great. So then we did 6 and 28, and that makes 34. So we're going to write this one down in our notes. We're going to take our time a little bit more. If you feel like you get this and you want to write it and show it your own work, go for it. This is right. This is our right answer. If you want to take your time and show your work a little bit more, if you look at this and you're like, what in the heck happened? Take your time with me, okay? So this is our last example today, problem number 4. We don't have a whole lot of time, so this will be our last problem. Number 4, we have 6 minus 7 times the quantity of 3y minus 4 plus 2y. So what's that part that we're going to distribute? Where do we see those parentheses? We have the parentheses around the 3y minus 4, so we're going to distribute that negative 7. Pew! Pew! Okay? If you want to write that out, it's negative 7 times 3y. And then we're going to do negative 7 times, what's the other part? Negative 4. What? Because it was a minus 4, we're going to keep it a negative 4. Yep. So what is negative 7 times 3? Negative 21. Negative 7 times negative 4. We get that positive 28. I'll zoom in a little bit, sorry. And then we're going to copy down those other parts so that 6 stays in front. And in the back we still have that 2y. We're going to combine those y's together. And we're going to combine our constants together. So what is negative 21 plus 2? Negative 19. All right, there is no homework tonight. Sorry that we finished that up on the last little part there. If you need to take a quick picture, take a quick picture. Otherwise, I'll put this up tomorrow so you can copy if you didn't finish it. Nice job today. No homework tonight. What is the plus one from? So because we treated this 7 as a negative 7, we can put a plus sign here. You can. If you make this a minus, though, when we do a minus negative 21, remember we subtract the negative, that would be like that. So we could either write this as 6 minus 21 or 6 plus 9. We went to minus 6 minus 1, but not 6 minus negative 1. Does that make sense? Oh, yeah. Same thing. It's like my name is Miss Morale, but some people say Moral. Same thing. You got it. Nice job. Good job today. You crushed it. No, didn't crush it.
We're gonna have more today.
Lots today.
Okay.
I like to
Do you? I don't. Oh my gosh, what is happening over